Hey guys, welcome to the channel vibgyoroftalents. So from today's video, we are going to be starting up with this brand new chapter, Trigonometry. As I've promised in the previous video that many people are feeling difficult in this particular chapter, I'm going to do a complete series based on this. This is going to be the first video of the series Trigonometry, but this is not actually related to exams or in exam point of view. This is just for more information. So if you would like to get more information, I would recommend you to watch this. But if you want to just get more marks in exam, so I would recommend you to watch the next video that is going to come on this channel. But this is going to be completely helpful as this is concept based. So let's get started. So by looking at the word itself, you'll know that this word trigonometry is something to do with triangles and their measurements. I felt like that. Didn't you feel the same? Alright, so actually this word trigon typically means triangle, and whereas metron just means measure, as we thought, GG. So right before, I was just thinking, why don't we have something like quadrinometry or even something more weird like pentanometry? You haven't heard this term yet before, but you might have heard about trigonometry. Have you ever heard about quadrinometry and pentanometry? No, you might not have heard because they actually don't even exist. So as we have many shapes like pentagons and quadrilaterals, why do we want to know only about these right angles and the right triangles? So, are all things in the world made up of triangles? Alright, so let's not get worried about thinking about so many questions, and let's try to look at some of the answers that we know of these triangles. So trigonometry is basically the study of shapes itself. So as we are talking about shape, let's just quickly take a square with a side of 5 centimeters. Alright? And let's also take a rhombus of side 5 centimeters, as if we just take square, it might be feeling alone. So let's get its friend rhombus. So make sure that it's just friendly with it and they're just playing. Okay, alright. So we have taken a rhombus of side 5 centimeters. So would you say these two are of the same shape? Obviously not, right? We also gave them different names as square and rhombus because of the only reason that they are not the same shape. So what's same in them? Look keenly. So we know that the sides are same in both the rhombus and squares. And if we see what are different, we can say that the angles are not same in both of them. In the square we have all right angle triangles, but it's not in the case of a rhombus. You cannot see all right angle triangles, right? So that tells us that angles are somehow helpful to determine the shape. So we now know that angles in shape are really important. So are only angles important? Nothing else are important to determine that two shapes are of the same? So now let's get rid of this rhombus, we got bored with it, and let's invite Mr. Rectangle into our investigation room to investigate it actually. Alright, so we will take one side as 3 centimeters in this rectangle and let's take the other one as 2 centimeters. Now, are these two of the same shape? I wonder. Oh, by looking at itself, we might know that they are not of the same shape. That's the reason also in the same here we gave them different names. By looking at it also you can say that they are completely different. They don't even look same. And in here we have right angles in both these shapes. Yeah, you see them here. So what's the problem here? So sides somehow seem to be the problem over here, right? So in the square we have 5 and 5. And in the rectangle we have 2 and 3 centimeters respectively. So they don't look same. So there is something to do with the sides too. But we don't know yet what's the issue. So let's call another shape for interrogation. This time let's call Mr. Square's big brother. Oh, what is Mr. Square's big brother by the way? Of course it would be a square, but bigger square because it's a bigger brother. Ha ha ha. So let's take a square with the side 6 centimeters. Now are these two the same shape? Look keenly. Yes, right, they are of the same shape. They definitely look the same, but just they are not of the same size. So the angles are also same in both of them. They are all right angles, but the sides are not the same if you observe. So then why do we say that they are of the same shape? One other interesting question. So now let's do something very sneaky. So let's put the smaller square on top of the bigger square. And now if I magnify the smaller square of 5 centimeters, what do we see? Then we will see that at some point both these squares exactly coincide. So that's the reason we said that they are of the same shape. Now actually, why do they even coincide? One more interesting question. So let's split them back again. Now if we try to see the ratios of these particular shapes here, the first ratio would be 5:5 because the square has one side as 5 centimeters and the other side to 5 centimeters. And if we take the square's big brother, that is the 6 centimeter square, the ratio would be 6:6, right? Of course, if we try to simplify the ratio of the 5:5 centimeter square, we would get the ratio as 1:1. And if we try to do the same with the big square, it would become 1:1. So basically, the ratio of both of them are 1:1. The ratio of both would be exactly 1:1. So that is the reason why the squares exactly coincided. Cool, right? So by this, we understand that not the sides are actually important, but actually the ratios of those sides are important. And we already found that the angles are important for shapes. Basically, we can say that the same shapes have equal angles and the ratio of the sides is the same. So this chapter is about triangles. But why on earth are we speaking about all other shapes other than triangles? So little patient. We'll come to our triangles just right now. Okay, so let's just draw a triangle and let's consider the angles in this triangle. So let's take one angle as 40 degrees, one as 80 degrees and the other as 60 degrees. So this is the only and only triangle that we can draw in terms of this shape. Of course, I can have many sizes of the same triangle. I can zoom into this triangle and I will have a bigger triangle than I had before. And if I try to zoom out of this particular triangle, then I would just have a smaller triangle. Nothing changes. Thus, we are zooming in and zooming it out. So, we can have a wide range of triangles in terms of size, but they would be exactly equal. That is, the ratios would be same for all of them. Keep this point in your mind. So, which seems to tell us that in case of triangles, somehow the angle alone is just enough to tell us the shape. So we don't really need the ratio of the sides. Can you guess what's the reason behind it? So yeah, let's look at the reason for why it is true. Alright, so from similarity, we get to know that when two angles of one triangle are equal to two corresponding angles of the other triangle, the two triangles are similar. So you would learn this in this chapter of similarity. So when two sides are similar, the ratio of their corresponding sides is also equal. So we can say that by AA test of similarity, we can prove this exactly. AA similarity is nothing but angle-angle similarity. If two angles are equal, then the entire triangle is similar to each other. So similarity is nothing but the same shape. So we just try to complicate stuff and make it look fancy, because if it was just simple, then all the people would learn it and it is not looking more complicated and more professional. So to get the professional look of it, we try to change the things and just try to complicate things. We don't like to keep the same names that we learned when we were kids, just as similarity or the same shape. We will just complicate it to make it similarity and something else. So now if I take these two particular triangles, these two triangles would be similar. So which typically means that the ratio of their sides is the same, right? So if we try to actually write it, it would be like A by D is equal to B by E is equal to C by F. So what we have learned in similarity is that from that we have implicated these and we have got A by D is equal to B by E is equal to C by F. So But in the earlier case, when we were looking at rectangles, we saw that the ratio of the rectangle within itself, not of the rectangle with any other rectangle, but we were just seeing of its length with of its breadth. So we can do the same thing here with our triangles too. So nothing to do much at all. We have already got the equation before itself. Now we just have to cross multiply these. So if you try to cross multiply, the first equation that we will get is a by b is equal to d by e. So these equations, these sides would actually be equal, and then b by c would be equal to e by f, and also c by a is equal to f by d. All great. Let's just jump ahead. So now, if I get this particular triangle, it has 3 angles. So did I really need to tell you that one was 40, the other has 60, and one more has 80? Not at all, right? I could have just told you that this is 60 degrees and one is 80 degrees, and you would have easily figured out the third angle out by just using the angle sum property, which is that if we try to add all the angles in a triangle, it would be 180 degrees. So if I just tell you one is 40 and other is 60, you would definitely figure out that the other one is 80. So what's the reason? 40 plus 60 is 100 and 180 minus 100 will be 80 degrees. Super simple. We have learned about this in the previous classes also. From many years we have been learning about this angle sum property, and we have also used it in many situations. So now we have only 2 angles which are required, and now we are going to try to figure out the ratios, because only then we'll be able to know the triangle completely. So the number of triangles you'll have to remember if you did it this way is that you might have the triangles in various combinations with different types of angles. In the previous case we took 40, 60, 80. It might be in different ways. Your mind would actually blow up if you actually have to remember all those combinations. So we don't want to do so much of work. We have to do so much of work to find out something? Oh, I don't really like that idea. You know something? We human beings by nature are extremely lazy. People say that necessity is the mother of all inventions. But I would say laziness is the mother of all invention. Isn't it true? Don't you feel the same way? Let me know in the comments below. Alright, so people didn't actually want to remember 2 angles. So they thought, why can't we fix one angle as constant and other will be able to know automatically. So the one angle would be fixed at 90 degrees. So the 90 degree angle looked cool, so they just put one angle as 90 degrees. So as we fixed one angle as 90 degrees, now that I have to remember only one more angle, that's it. It might be more simpler. So that might not be the smartest thing to do, right? Fixed one angle to 90 degrees, so I got a right angle triangle. But what's the use of this right angle triangle? Not all objects that we see around us are 90 degrees, are they? But yeah, I'll tell you a cool fact now. Now, if I just take this particular triangle and if I just try to exactly cut it in middle, what would you see? You would just see that it has got split into 2 right angle triangles. Try to take any other triangle and I will promise you that in some way or the other you will be able to cut this triangle or any other triangle into exactly 2 right angle triangles. So yeah, that is it for today guys, and I hope you have learned something new in today's video, and please make sure to follow us on Discord, Twitter and Instagram. All the links will be in the description, and please make sure to subscribe to the channel and hit the bell icon so that you'll get the notifications of all the latest videos of our channel. And as I said to you, this is just for information. This video is just for information. And the next video will be about all the things that we are going to be actually learning in exam point of view. And thanks a lot for watching. And if you like this video, please make sure to drop a like.